Hey guys, so we're gonna go over I guess day 1 notes for our new unit 9 stoichiometry, and it does go back to moles. Okay, so if moles wasn't your thing, well, you're not gonna have any choice but to learn it this time. Alright, so to review moles, okay, for conversions between mass, volume of gas, and the number of particles, we use the mole map to guide our dimensional analysis. So what dimensional analysis is basically just converting from one factor or one unit to another. Okay, so dimensional analysis review. With dimensional analysis, you have to multiply the given by one or more conversion factors in the form of a fraction. So what your conversion factors are is these right here. Your volume, so 1 mole equals 22.4 liters, or 1 mole equals molar mass, or 1 mole equals 6.02 times 10 to the 23rd particles. Okay, so that's what your conversion factors are. So let's go ahead and do a different example for now. So let's say I asked you how many donuts are in 3 dozen donuts. Well, if your conversion factor is 1 dozen donuts equals 12 donuts, well, in your dimensional analysis, your given is always going to go first, and you're going to multiply that by your conversion factor. So remember, when you're doing your conversion factor, what you're looking for or what you've been asked to find always goes on top. So in this case, I'm looking for how many donuts. Okay, so that'll let you know that our 12 donuts are going to go on top and the 1 donuts is going to go on bottom. Okay, because remember, in dimensional analysis, these have to cancel out. So dozen donuts needs to cancel out dozen donuts, so that my end unit is just donuts. Okay, so to solve this problem, we are going to multiply 3 times 12 and then divide by 1, which is going to equal 36 over 1. Okay, but of course the 1 is really insignificant, so we can just say 36 donuts. Okay, now this isn't in your notes, but remember that our general formula, like the minimum equation or formula for moles, is going to be your given times what your times your conversion factor. And then remember, your conversion factor, that's your mole map. Okay, these right here, your 1 mole equals molar mass, your 1 mole equals 6.02, your 1 mole equals 22.4. These are your conversion factors. So that's what you're going to put here. That's what you're going to multiply by. Okay, whatever you're trying to look for goes on top, and then whatever you were given is going to go on the bottom. So for example, if you were given liters and you were asked to find moles, well, which conversion factor are you going to use? Well, again, you were given liters, so that's here, and you are looking for moles. So this is the conversion factor that you're going to be looking for. Okay, so again, if you were given liters, then your 22.4 is going to go on the bottom, and then your 1 mole is going to go on top. Okay, so again, this is just your general equation. It's going to change for your multi-step and for your other problems that we're going to be learning how to do. Okay, so again, this is just a general equation. Alright, so again, these are your conversion factors. Remember that your molar mass is from the periodic table. So if you were asked what is the molar mass of, let's say, helium, well, you would just go on your periodic table. What's your molar mass for helium? If you look, it's actually 4.003. That would be your molar mass for helium. Okay, your 1 mole equals 6.02 times 10 to the 23rd particles. Remember that atoms, ions, molecules, and formula units, those are all particles. Okay, and then your 1 mole equals 22.4 liters of gas at STP. These two values are never going to change. It is always going to be the 6.02. It's always going to be 22.4. Really, the only conversion factor that you have to be careful with and calculate is molar mass. Okay. Another thing that I was asking you guys in class is, what does STP stand for, and is it important for our calculations? And the answer is STP stands for standard temperature and pressure. Okay, do we really need it for our calculations? No. It's just letting you know that the gas that we're looking at is stable. It's standard. Okay, so it's not really that important for our calculations. Okay, so we're going to go ahead and take a look at our practice problems now. So let me go ahead and switch over to our document camera. Okay, let's see if it decides to work, because sometimes it freezes up just like that. We're going to need our periodic table. Okay, and let's see if, oh no, don't freak out on me now. Okay, and it looks like it freaked out. Okay, so I'm going to have to stop the video, close the program, and try again. So I guess just go to video 2 for today. Okay, give me guys, yeah, I'm going to have to stop the video. Sorry guys.